Друзья, встречайте, DevOps Engineer at Proxima, Amina Saidakhmedova. Amina, прошу, сцена ваша.
All right. Hi, everyone. The topic is a forensic Elasticsearch story, a story about a screaming server that was actually completely silent. My name is Amina, and I'm a DevOps engineer at Proxima. I've been in this field for a year now, and they say that your first year is for learning, but usually you learn much more from one broken production than from 100 tutorials. A client came to us for an infrastructure audit, and we found the system that was effectively paralyzed. On the upper graph, you can see that starting in December, the load average started its abnormal steady climb, reaching a peak of 1,945. Meanwhile, the CPU was 92% idle, pretty much all the time, and you can see that on the graph below the first one. For any engineer, this is a clear sign of I/O wait. The system is not working, it is waiting for something. Another anomaly was a single Elasticsearch index that reached 590 gigabytes and kept growing. So what exactly happened in that December? One day, I found an NFS server that was mounted in a hard mode. Hard mode guarantees that your data is going to be written no matter what. But in our case, it became a trap. The thing is, that NFS was already dead, but due to the hard mode, Elasticsearch tried to save its snapshots to that dead server so much that it just stopped everything else. The letter D on the screenshot is for D state, which is uninterruptible sleep. So the kernel threads are frozen forever. And the dmask log confirms that by saying, NFS, no answer, still trying, timeout. Another problem was with the index lifecycle management. In January, these were almost 100% full, and we had to clean them up manually to win more time. Turned out that no deletion phase was configured. The logs were meant to live forever. And the last one, the architecture debt. They used Elastic Agent to dump everything, logs, metrics, APM, into a single stream, no filtering, no separation between namespaces. They couldn't even give access to staging logs without exposing production. So we chose to redesign the whole flow. First thing, I bootstrapped 3 nodes for the new Elasticsearch cluster. Previously, they had only 2 nodes, but in such case, you're just one network glitch away from the split brain. Basically, if node A doesn't see node B, both of them assume that the other one is dead and try to become the master. And without the third node, the quorum, the tiebreaker, you end up with 2 brains writing data at the same time and ruin your data integrity. Then we chose Fluent Beat over a simple Elastic Agent. My first instinct was Logstash, because it's powerful, has great filtering, but since it runs on JVM, it requires a separate server just to exist. Meanwhile, Fluent Beat, it's written in C, takes around 50 megabytes of your RAM, and runs as a daemon set inside the Kubernetes cluster we already had. On the screenshot, you can see that I used rewrite tag to separate logs by namespaces on the fly, and I set the keep parameter to false to ensure that once a log is re-tagged, the original record is discarded. Then, by enabling the logstash format on, Fluent Beat automatically names indexes like logs pro 2026-05-15, for example, so prefix with the current date. And later, I had to add a Lua script that extracts trace IDs from log messages into a separate field so that developers can search all the related logs just by pasting that ID in Kibana. And the last step was to sit down with business and define a proper hot, warm delete phases for the ILM configuration. And here are my key takeaways here. First one, high load average plus idle CPU is IO weight. Don't just look at your app. Check your network and storage mounts first. Second, reliability can be a double-edged sword. Hard mount is great for data, but without proper monitoring, it can be a silent killer. Third one, own your data. Don't just collect everything. Filter at the edge, separate environments, and always know when to say goodbye to your old logs. Solving a 5-month-old mystery was a hell of a ride, but it taught me that in DevOps, you don't just manage the tools, you manage the logic and connection between them. And this is the end of the story. Feel free to catch me during the break, connect me on the LinkedIn, and thank you very much.
Amina, thank you. Maybe